All right, so this is problem 1.6.67. We're solving and we have the absolute value of something greater than something. When you're dealing with an absolute value that's greater than, the definition is to take the inside and set it greater than the number, or it's a compound inequality. 3x plus 2 over the x minus 2, you're going to set it less than the opposite of the number. Okay, so this right here is just the definition for an absolute value greater than a number. It's always a compound inequality that involves the word or. Okay, so we actually have two separate things to solve, and these two will be the solution of this one and the solution of this one. We will actually be using a union, because of the word or, of these two solution sets as our solution to the overall problem. Okay, so we need to solve these separately. So I'm going to, with inequalities that are rational, that have rational expressions in them, we need to isolate and get 0 on one side. So I'm going to subtract the 6. So that's what I'm looking at to start with, and I need to get a common denominator, so I'm going to multiply top and bottom by x minus 2 for the 6. Okay. And then I'm going to go ahead and take this negative 6 and distribute. So this is going to give me 3x plus 2. This is minus 6x plus 12. And this is all over x minus 2. Okay. If we collect like terms now, 3x minus 6x, that's negative 3x. This is plus 14. And this is all over x minus 2 and greater than 0. Okay, so we're gonna do a number line test point method to solve this from here, but let's go ahead and get this one down to the same position. All right, so I'm going to add 6. So we have 3x plus 2 over x minus 2 plus 6 less than 0. And then I'm going to, again, get a common denominator. So I'm going to multiply top and bottom by x minus 2. Okay, so if I distribute the 6, I have 6x minus 12. And collect like terms, I'm looking at 9x minus 10 over x minus 2 less than 0. Okay? All right, so let's do both of these separately, and then I will take the union as the solution. All right, so let's do the negative 3x plus 14 over x minus 2 first. Okay, so I'm going to take both of these and set them equal to 0 so that I can find, I call it the partition numbers. Those are just the numbers that we're going to break up our number line with to solve this. So subtract 14 here and divide by negative 3. It's going to give me x is a positive 14/3, and then over here x is equal to 2. Okay, so 14/3 is 4 2/3. So that's going to be to the right-hand side of my 2. And I'm breaking my number line up here, and then I'm going to choose test points in each of these regions. And I'm going to identify, actually going to plug them back into the test points. I'm going to plug back into this expression here and see whether I get a positive or a negative. Okay, so I'm going to choose 0 in this region, and I'll choose 3 in this region, and I'll choose 5 in this region. Okay. All right, so if I take 0 and I plug it in, I'm plugging it in for x. Just in this expression right here, I get 0 plus 14 over a negative 2. So that ends up being a negative answer. Okay. Oh, and by the way, we have open circles on both 2 and 4 2/3. We can't include the 2 because it gives a 0 in a denominator, and we're not including the 4 2/3 because we don't have equal to 0 here. Okay. When I plug in 3, I get a negative 9 plus 14, so the numerator is positive, and then the denominator is positive also. So I have a positive divided by a positive, which is going to make this region positive. Okay. And when I plug in 5, I get a negative over a positive, so this region will end up being negative. Okay, and what I'm doing, let me just write one of these out for you actually. What I'm doing is I'm just plugging it into that expression, and I actually don't even care what the number is, I care what the sign is. So I notice here, you know, that this is negative 15 plus 14 over 3. It's a negative 1/3. It's a negative number. So that's what tells me that it's negative in this region. Okay. All right. So now I just want to analyze my number line here. I'm looking for greater than 0. So I'm looking for something positive. So the region that I'm positive is this region right here. Okay. So for this piece of our answer, we're going from 2 out to 4 2/3, or in other words, 2 out to 14/3, and not including either of those points. Okay, so that's just for that one piece. Let's do this other piece here. This is 9x minus 10 over x minus 2 less than 0. And again, if I find the partition numbers here, set both the numerator and denominator equal to 0. So here 9x equals 10, so x is 10/9. And then over here, x is equal to 2. Okay. So 10/9 is 1 1/9, so it's going to be to the left-hand side of 2. And if I choose some test points, I'll choose 0 here. Let's choose 1 1/2 here. And let's choose 3 there. Okay. If I plug them in, again, I'm plugging them right back into this expression. So if I plug in 0, I'm going to get a negative 10 in the top and negative 2 in the bottom, so that'll give me a positive. Negative divided by negative is positive. If I plug in 1.5, I'm going to get a positive over a negative, so this region will be negative. And plug in 3, I have a positive over a positive, so this will be positive. Okay? All right. So if we analyze what we're looking for less than 0. So if you're going to be less than 0, you're going to be negative. So we're looking for the negative region. That's this region right here. So for this particular piece of the problem, 10/9 up to 2 would be our solution. Okay, so since we're dealing with an OR statement here, we actually need to include both of these. So 10/9 up to 2 is part of our solution. We need to union that with the other solution, which was 2 out to 14/3. Okay, so that would be the answer in this problem. And this union here has to do with the fact that it's an OR statement, and the OR statement has to do with the fact that we're dealing with an absolute value that's greater than. The definition is using a compound inequality with an OR.